All right. Welcome, everyone. This is IoT214. Welcome. We're going to talk about what's new with IoT device software. I'm Shyam Krishnamurthy. I'm the general manager for the device software team in AWS. And I'm joined by Catherine Dodd. She'll be here in a bit. And she's a senior technical program manager in the team and also one of our resident security experts. So really happy to have her join us today as well. And she'll be doing demos. And we'll go through everything we've done in the past and in the last few months with device software. We're going to go through the agenda, but I wanted to quickly just talk about my experience with IoT. So I've been in this space about 5 years now. And technically, IoT is very diverse, right? We're talking about all the way from tiny devices to cloud systems. So it's intellectually challenging. It's a lot of fun. But the thing that I really enjoy is learning what people are doing, customers are doing with IoT. The very first time I remember I joined the team, we had a customer conversation, and they were trying to solve how do they predict if things are going to fail, power equipment is going to fail along highways in the middle of the desert, right? Seemed like a little bit on the, the route to Vegas, but it was actually in a different continent altogether. And so from there, having conversations with people trying to improve medical diagnosis based on data they're collecting about patients, people trying to fix problems in mining, and really fun home automation scenarios. So it's really great to talk to customers, really great to see what all of you are able to build with the systems that we are able to provide. So today, we'll go over IoT device software, an overview of what exists today, a little bit of what we've built, and then about the new things that we've added in the last few months. And we'll talk a little bit about the framework of how we look at this, thinking really about autonomous systems. And I'm going to be prompting you to think about what your businesses are and what autonomous systems mean for you, and how open, secure, and data-driven services from us can really help you take advantage of the power of IoT. So that's what we're going to walk through. Before we dive too far in, I want to start with, if you've seen any of our other IoT slides, you'll recognize this next one, which is if you know the state of everything and you could reason on top of that data, what problems would you solve, right? So this is kind of the lens with which we talk to our customers. Our customers are looking at the problems. And the thing that independent of the domain, whether it's healthcare, home automation, manufacturing, smart manufacturing, people are trying to use IoT in a way to understand the physical world better, right? Understand the state of the physical world better, reason on top of that, make decisions on top of that, and then use that to further better business outcomes, right? Save money in businesses, predict failures before they happen, and fix that before it happens. Look at better business models where you can actually, make new services as you gain productivity. So all of these things are things that our customers are looking at solving by using IoT. And as you'll see in the next slide, we've got customers from sort of every domain: healthcare, scientific instrumentation, mining, manufacturing, home automation. And it's really exciting. Every time I talk to customers, there's a new use case where they've really used IoT to solve a real world problem. And that's the fun part of it. How many of you, just quick show of hands, are actually building IoT solutions that you hope to offer to your customers? All right. About 30%. How many of you are thinking of doing that in terms of improving automation or systems, or maybe your integrators trying to offer that to other companies? Okay, another 1/3 or so. And how many of you are partners who are working with us to bring common solutions to market to enable this whole ecosystem? Okay, a few more. Great. Good mix here in the audience. Great to see it. So when we think about this, right, when we think about understanding the state of the world and improving it, we'll dive into the device specific, but this is sort of the higher level theme. What does it take to actually make this happen, right? And there's a traditional sort of layer cake architecture diagram that we can talk about, right? How do you actually provide software that lets you build the devices, the hardware and the software that operate at the edge, from the tiny nodes to the gateways and the aggregators and the network subsystems in there, to the cloud connectivity and the control and the device management that lets these devices actually connect to the cloud and take advantage of all the other systems that are in their cloud. And lastly, the data services and the analytics services that you use to make sense of that data, to reason about it and say, okay, here, this signal from this particular heart rate monitor means that this anomaly is happening, and therefore I need to take this action, right? Being able to do that, you want to think of these 3 layers. But I prefer this version, which is actually the IoT, what we call the IoT virtuous cycle. Because as we see systems getting more and more sophisticated, oftentimes we're not just taking this data and then looking at it in just a dashboard, right? That's great, that's useful level 1. But people then try to drive the decisions back into the real world. Sometimes the decisions are manual, right? This equipment is going to fail, so let's page the operator and let's go fix that before it fails so that you don't have this, the manufacturing line being stopped and wasting thousands of dollars. At the same time, you're also seeing a lot of companies now really going forward and saying, how do I drive these back into physical systems, into the things at the edge? And those are the kinds of things we think about, is that the edge is not just the sensors and the tiny devices. These are also the equipment, the factories that are making things, the controllers, the actuators, that can actually now drive a real-time loop back into improving the physical world, right? So that's the context in which we look at it, and we're going to dive in to the device software part of it. So I manage the team that builds the device software in AWS IoT. And when we think about device software, right, this is, you could imagine this hotel has a bunch of potentially IoT systems, sensors in different rooms, a few PCs in a back room that's collecting all of that data and dynamically determining, how to adjust airflow, for example. You typically have the actual sensors and the controllers are constrained in some way, right? Sometimes they're constrained because they're running off of a battery on a wall and they have to be very conservative in how they're using power. Sometimes they're constrained in bandwidth because they're in the middle of a farm, they're collecting humidity data that you need to then use to optimize your crop output. And sometimes it's constrained because it costs a lot of money to buy very sophisticated processors, and you want to actually deploy millions of these devices out in the world. So you want low-cost devices. So typically, when you look at low-cost devices, we use microcontrollers. And traditionally, people have built embedded systems, right? Controllers, sensors, and so on with microcontrollers. This is a very mature industry. But now, when we talk about IoT, we're taking these devices and now we're connecting them. And that's where we have FreeRTOS and Amazon FreeRTOS, where we took the popular embedded operating system, open source FreeRTOS. It's a real-time operating system, very tiny, can run on microcontrollers with just a few kilobytes of memory. And we've added things that help these devices now participate in the IoT ecosystem. So first, local connectivity. I can take these devices, I can connect to other systems with over Wi-Fi, over Ethernet. And earlier this year, we added the capability at GA to connect over Bluetooth Low Energy to a phone, which could then connect and send data to the cloud. And then we added cloud connectivity libraries. So if you're familiar with the IoT core side, the cloud connectivity services, MQTT and HTTP are two of the protocols we support. So we've added support for MQTT and HTTP. And you could also connect to IoT core. You could connect to your own private systems as well. Because these are open source libraries that we make available as part of the FreeRTOS project. Then we've added security. The minute you take these embedded systems that traditionally used to be isolated and you put them in the internet, you have to make sure that it's secure. And that's a very key priority for us. And we started with both communication security, so TLS and cryptography, plus storage of the keys. So you can store these keys, and Catherine will talk a little bit more about the secure element support we've added earlier this year. But whether you're using a secure element or not, we added PKCS 11 abstractions. And last but not least, as soon as you connect these devices, at the very minimum for security patching, but also unlocking the possibility that you now have embedded devices that can improve and get better over time, we've added over-the-air updates and code signing services in the cloud. So we have an agent that runs on the embedded device and a cloud service that can cooperate and send the message down. You can fetch the message yourself over an HTTP connection, or we can actually stream that image over the MQTT connection to conserve memory on the device when you're opening TLS connections to the cloud. So because these devices, again, many times have 100 kilobytes of RAM, 200 kilobytes of RAM, and every TLS connection takes memory, right? So that's what we added, and this has been available for a few years. And we have, customers using this, building lots of products. Let's take one example, right? Let's think about virtual assistants. All of you have, heard about Alexa and other voice assistants. And now we have customers, or actually companies or customers of ours working with us and saying, okay, how can I bring the value of voice-enabled services to lower-cost devices that they're manufacturing? And a couple of things that we've launched this year have actually contributed to helping here. So I want to talk about iDevices. iDevices is a company that makes smart devices. They have a portfolio of different devices, and they wanted to build a Alexa-enabled light switch. And so they launched the Instinct, which has a microcontroller in it, which runs Amazon FreeRTOS, works with AWS IoT, and offloads the Alexa services to Alexa voice services. We also launched Alexa voice services for AWS IoT. And the device itself is running Amazon FreeRTOS, is able to collect the data, send that securely over MQTT to the cloud. So this is an example of how we can take something that was traditionally, found on larger classes of systems and bring it down to the footprint of a microcontroller. Next, when we think about the edge, it's not just the tiny devices, right? Sometimes these tiny devices are connecting directly to the cloud. Many times they're using, as I said, they're conserving battery, so they're using Bluetooth low energy. Maybe they're in a factory and they're using a local Ethernet Modbus over TCP on that, or they're using a SCADA system. And these networks then may need a bridge, a gateway, an aggregator before sending that data to the cloud. And that's where we talk about how do I, instead of just providing a thin layer that just forwards all of that, a router to the cloud, how do we actually look at these use cases and say, well, sometimes you have to proxy that data to the cloud. Sometimes you have to make local decisions. Again, going back to these constraints, some of these constraints that I talked about, like connectivity, apply not just to the tiny devices, but to the entire environment. You imagine an oil rig, right? And there's a number of sensors and so on, but that connectivity on that oil rig is very limited. So the gateways and the aggregators there have to perform some functions as well. So that's where we have AWS IoT Greengrass, which really is software that helps you bring a lot of the cloud capabilities to the edge. It can act both in the mode of helping you filter and send data to the cloud, but also bring in functionality locally at the edge. So we brought in message brokers, Lambda functions, so you can program these devices, device shadows, so that you can actually store state on these devices, as well as the ability to store your keys, both for access to AWS IoT, but to other services. You may be able to access AWS IoT, but also store some data in S3, for example. And you can store your keys and credentials using the security managers available in IoT Greengrass. We added local resource access that lets you actually get access to the sensor data or work over USB. And so Greengrass is software that runs on Linux and regular operating systems on gateway class devices. So it's a little bit different from FreeRTOS, but the combination is powerful because now you get at different footprints on the edge, you run these systems and they can act in multiple modes depending on the use cases that you're trying to solve. And last but not least, we also have over-the-air updates. So these are the foundational components of Greengrass, right? On top of that, there's a few more things that Catherine will go over in terms of machine learning and a few additional services as well. So we have all of these. Let's talk about, okay, how does that get used? I'm going to use an internal example. So we have an Amazon team that was looking at the Kindle team. They're building Kindle devices, and they want to test that in each of the countries that they deliver to. And sometimes you actually have to take these devices physically to those countries to test it because the environmental constraints are different. The Wi-Fi regulations and which bands you can use are different. The thickness of the walls and the construction is different, right? So you have to test it locally, figure out how well it works. But the team here, the engineering team, also wanted to have centralized view of, okay, how are the tests doing? What's passing? What's failing? Can I quickly iterate and be agile on how I solve and get to market? And so they were actually able to take Greengrass and build a test rig that So the Greengrass device is running on the board underneath. We've got the Kindle device, and this is a test rig that they put together, and they were able to ship it to all the countries, and that test rig has Greengrass running. Operator can essentially deploy test cases from the main engineering team to each of these devices. The Greengrass node has Lambda functions that are programmed to run those test cases, collect the results from the Kindle device, ship that back to the cloud, and then the engineer gets a central view, okay, which regions are failing, or there are common patterns across different regions, how do I diagnose it, and so on. So how does this work? So an example, the architecture that they used is they have a website for the test operator running on EC2. I've simplified it, right? There's going to be load balancers and instances and so on and so forth. But essentially, they have a website running on EC2 that's storing. So I am a test operator. I'm creating a test job that I want to deploy to, say, 3 countries where I'm testing the Kindles. We store those test jobs, send that to a queue for that job to be deployed, and the Amazon Simple Queue service allows you to have a queue of different activities. And AWS Lambda, which is our serverless compute offering, allows you to take entries from the queue, process them, and push those as messages through IoT Core. And IoT Core is our cloud service, which allows you to do messaging and over MQTT or HTTP between devices and with the cloud. And in this case, the IoT Core message would actually be delivered to the Greengrass node that you saw in that test rig, which over USB would deploy the tests, run those tests, collect the data, and then send that back to S3 to store those results. It's great, right? So now the same test rig, single engineer or set of engineers can deploy that to all the countries. They have people helping them set up the device, the Kindles, powering them on, and so on. But once it's ready, they can run that, and then they can have a single place to view it. This data, again, S3, you can actually have Lambda functions pick that up. So we send those metrics to CloudWatch, so I can have a quick view of how many tests passed and how many tests failed in a given build. And then I can also send that to Elasticsearch, which is one of our services, where we can then search these logs, go through the actual details of the failure, diagnose that, fix it, and deploy another build. So this is an example where Greengrass on the device side and the cloud cooperatively solve the problem that we had internally. So this is great. So you've got FreeRTOS running on small microcontroller devices. You've got Greengrass running on your gateways. As a customer, how do you know if it'll work with your hardware? So we have a product called the IoT Device Tester. It's a tool that you can use. It's available for both Greengrass and for FreeRTOS. In the case of FreeRTOS, because these tiny microcontrollers have very different drivers depending on the chipset being used and so on, we have a standard abstraction layer that we work with our partners to port these to. So the device tester will validate that it's compatible, that the microcontroller and the ports work well with Amazon FreeRTOS. In the case of Greengrass, it runs on Linux, but you have specific dependencies, so our device tester will actually verify that all the dependencies are there. And it's available for download from both the Greengrass and FreeRTOS product pages for free. How do you use, what value does device tester give you as a partner? You can actually use it to check that your hardware works with our software and get listed in a device catalog. So we have a catalog of all the devices that work with IoT using FreeRTOS, using Greengrass, or directly using your own systems that's available on our partner site. And our partners list many different devices on that. As a customer, you can use Device Tester to verify your initial ports work if you have a custom board, for example. Or you can also just go to the device catalog and find the set of devices that we've already worked with a wide range of partners to qualify. So here's an example of partners who we've worked with. And if you're a partner working on getting devices, you're in good company here. So that's what we have today. But before I head into sort of what's new, I want to set the stage a little bit with going back to the mission statement, right? Okay, there. So we have these software that runs on the devices. It fits into this larger scheme of AWS IoT, where device software communicates with the cloud, you reason on top of it, and drive decisions back. And you combine that with that virtuous cycle that we talked about, what we're actually getting to and whether some companies do it today or they do it 10 years from now, is together these are going to build autonomous systems, right? These autonomous systems are going to help shape the physical world to be more efficient, whether that's better productivity for businesses, your smarter manufacturing, better diagnosis in healthcare, all of these. So what I would prompt you to think about is if you're solving a business problem using IoT, what does full autonomy mean? Can you do business differently, right? With full autonomous systems that can use this virtuous cycle of IoT. But it's not a straight path there, right? Sometimes you can go straight to it, and because you're building a brand new product and you can get autonomous systems. But sometimes you're changing a factory, to do smart manufacturing. There's going to be SCADA systems in that factory from 10 years ago that might live for the next 15 years. And you can't, rip and replace an entire manufacturing facility. So you're going to change systems over time, right? And so you're going to have some customers who can leap to autonomy and some who are going to do incremental, and both are okay. Question is, as you think through that roadmap to autonomy, we started saying, okay, how can we help our customers? Because we heard this message, okay, we've got Greengrass, we use it for this, but in this other case, we needed to work with existing systems. So we have FreeRTOS, but we need to decompose these modules. So as we thought about it, we think there are 3 key things that can help customers on that road to really solving hard business problems with that path to autonomous systems. The first is we need our systems to be open. We need our systems then to be secure, and we need them to be data-driven. Let me talk about what these mean, right? If you have an open system, you can take the software that we provide and you can integrate that with existing systems that you have so that you can do incremental change. Why does secure matter? You're in the physical world. In addition to sort of the standard security practices that we have to build for software, we have to think about additional threats, right? I can get my hands on the device. What happens then? Can I hack into it? So the threats are different. The impact in the physical world of security threats are different as well, so we have to pay a lot of attention to that. And the third is the food for that whole virtuous life cycle is data, right? So we want to provide you systems that really help drive data through the system, make it easy for you to collect and manage that data. And so when we talk about what's new with IoT device software, I talked about a few things that we've launched, like HTTP and Bluetooth and so on. But we're going to talk about a bunch more, and we're going to talk about this in the context of open, secure, and data-driven systems, because we think that's what leads you to be able to put them together into your problem solving, to solve your problem in a fully autonomous system way. So let's start with open. Of course, that's what gives you the flexibility to pursue that path. So let's start with open. We'll talk about Greengrass first. I'm happy that we were able to launch last week support for containers, right? So previously, you could only deploy Lambda functions to Greengrass. So if you wanted to program a Greengrass node, you could do it with Lambda functions. That's great for some use cases, but not so great if you have an existing application where you're already sending sensor data to, say, a local database, in addition to sending that to the cloud. Maybe you have manufacturing execution systems that are running alongside on your aggregators, and you need those to continue working on the same devices. So last week, we launched this service where you can take existing applications, you can package these existing applications into container images using Docker, and you can deploy these Docker images into a Greengrass node. AWS IoT Greengrass will actually, when you deploy a Greengrass device, you can specify a reference to a Docker image. Upon deployment, we'll deploy Greengrass, and we'll actually pull down the Docker image, instantiate that. The requirement, the Docker runtime has to be installed, but then we instantiate the actual Docker image and get that going. So now you can imagine essentially being able to use Greengrass along with existing systems, whether that's your own new system that you just prefer to use a different runtime to author, or you've got third-party systems, or you've got legacy applications. All of those are now interoperable on Greengrass, so we're very excited with this. Where can you get this? So you can pull images from the Amazon Elastic Container Registry. You can also pull images from Docker Hub itself. And if you have some custom applications in your own private repository, you can do that too. So that's part of us looking at, okay, how can we be more open, and how can we help you take the pieces that we have and build the systems, whether you're able to go to that full autonomous system now, or you want to go there in stages. AdLink is a partner of ours. Very happy to partner with them. They build gateways for the edge. So at the IoT edge, they have customers spanning, manufacturing, asset tracking, and so on, where they make hardware, and they deliver that, and their customers then customize that to different verticals. They prepackage Greengrass with these gateways so that their customers can then program them for specific functions. And now with the container support, they're able to now make their gateways much more usable for their customers, because customers can then mix and match additional applications they already had and deploy those to the gateways. So sometimes, for example, you have the AdLink gateways that are doing the data collection and aggregation and full edge to cloud solutions, but they might have authorization systems and other systems that they need to run at the same time on the same gateways, and they're able to do that now with the capabilities that we have. On the FreeRTOS side, what does openness mean? So very early on, we started with FreeRTOS has always been open source. When we took stewardship of that, and with Amazon FreeRTOS, all our development is done on GitHub. It's MIT licensed, it's open and free. In addition, earlier this year, we were able to start accepting contributions. And we also work very closely with a wide variety of semiconductor manufacturers. And so that part of all our work is available in the device catalog. So source code is open. Our catalog of partners is available for you to look at. And on the hardware side, the kernel of FreeRTOS, which is the operating system, is actually ported to various different architectures. And we're very happy earlier this year we were able to add support for the RISC-V architecture. So if you're not familiar with RISC-V, it's a open hardware architecture. So any company who's able to build chips can actually use this hardware architecture and build their own chips. And there are companies that are now really embracing RISC-V, and we're very happy to have both real hardware and emulators that now support FreeRTOS running on RISC-V chips. So if you're thinking about a custom project, you have open source software now with open hardware schemes that you can do to build devices. And if you're a customer looking to just use one, we have partners who are building RISC-V chips that you can use for your systems. So that's my section where I talk about what openness means and how that leads you on your path to autonomous. I want to hand it over to Catherine. As I said, she is much more experienced in security than I am, so it's a good section for the secure section. So thank you, Catherine.
Thanks, John. All right, so we've walked through how we are focused on building an open device software ecosystem. We're also focused on making sure it's secure. We're focused on making sure it's data-driven. I'm going to walk through those pieces, and then at the end here, I'm going to be doing a demo. So when we talk about secure, what do we mean? What I really want to focus on here is that we've baked security into what we've built from day one. So we don't want you to have to be reinventing the wheel. We don't want you to have to write crypto libraries. We do that on your behalf, and you can use those components to build and solve your business problems. So let's take a look at what this means in practice. So what do we have out of the box today? First off, we support mutual authentication, both at the edge, so between two devices, say a FreeRTOS device and a Greengrass device. We also support mutual authentication between a Greengrass core gateway and the AWS cloud. So that whether it's that edge communication or that gateway to the cloud communication, that communication is happening securely, encrypted using industry standard TLS. We also provide support for managing your credentials from the cloud side using AWS IoT Greengrass. So we have a service that lets you integrate with the AWS Secrets Manager. So you can store your credentials cloud side using Secrets Manager, and then when you need to use those on an edge device, you can deploy that down securely and use those credentials. So a great example of this is if you're doing any integration with a third-party API. So if you're calling Twilio, you're calling ServiceNow APIs, you can store those credentials cloud side. You can do any credential rotation cloud side, and then deploy those dynamically down to your edge devices. And we found this is really helpful for customers who are working in regulated industries where they may have regulatory constraints around how often they need to be rotating credentials. It also means for the rest of you who maybe don't necessarily have those constraints, there's still no excuse for hard coding credentials. So, and finally, we have our secure element support. So secure element, folks also use the term hardware root of trust. Sham alluded to this. So we've had that support. We launched it about a year ago for Greengrass, and we've launched this support for secure elements for FreeRTOS just about a month ago. So let me dig into kind of what this looks like from the FreeRTOS side. I'm going to skip ahead a little bit because I like pictures. So what does it look like if you're running FreeRTOS on a microcontroller? So this is kind of the 10,000-foot view. At the very lowest layer there, you'll have the partner-supplied drivers. The middle layer there, you've got your FreeRTOS kernel, and then any libraries you're going to be using. So on here, I've got the TLS library, and then your code sitting on top. So the important thing I want to point out here is that if you're doing any encryption, that's all happening on that microcontroller. So how does that change once we have a secure element? So once we have a secure element, so this is going to be storing all of our key material. So it stores it in a tamper-proof way. And you can see our picture has shifted a little bit. So we've got two new components on the microcontroller side. We've got our Amazon FreeRTOS, our PKCS11 support. And then we've got partner-supplied PKCS11 modules as well. So today we have two partners who have already published support for their silicon, so Microchip and Infineon, and we expect that number to continue to grow. So, whoops. All right, back on track. Okay. So why would folks be using a secure element? So, the 101 is that it allows you to store your key material in a tamper-proof manner. As I mentioned, we're using an open standard, PKCS11. The main thing that customers are getting out of using these modules is that it enables them to install devices in locations that they may not physically control and have a lot more comfort doing so. So a great example of something like this is we have an internal team, Amazon Key for Business, and they build smart fobs that enable delivery drivers to have access to commercial buildings. So we have a great blog post out there about kind of how they're using our services, and this is one consideration that they had. These devices are going into apartment buildings. We don't necessarily have physical control over those devices, so it's important to them to have this support. And finally, once you're offloading that cryptographic processing, and it's no longer taking place on the microcontroller, so now all of that processing actually happens on the secure element. So it's happening in hardware on that element, and that relieves that kind of offloads some memory space, frees up some memory space on the microcontroller side, and has the potential to reduce your power consumption. So we've covered secure and some of the components that we give you to be secure. What do we mean when we talk about data-driven? So this really kind of ties back into our point about, if you have this data, if you're able to reason about it, what are the types of things that you're going to be able to do? So what do we provide out of the box today in terms of being focused on being data-driven? So with Greengrass, we provide you with connectors. So what's a connector? Think of it as a pre-built Lambda function. It enables you to quickly configure and deploy functionality without having to write code. All you have to do is insert some configuration information cloud side, and you're off and running with that functionality. So a couple of examples are we support a Twilio connector, Splunk, ServiceNow. Those are some of the integrations that we support. The next piece that we have is device shadows. And really the core piece that you get out of using device shadows is that it enables you to have sort of this write once functionality. So regardless of whether your device out in the field is connected or disconnected, you can write, say, a command, a state change to the cloud side service, and that device shadow will then sync up with your device once it comes back online. So that ensures that your device always has the correct state. And finally, we enable machine learning inference at the edge. So what you can do with AWS Greengrass is that it enables you to train, run, improve your models in the cloud, and then deploy those out to your edge devices to do that inference locally on those edge devices. And this last bit around machine learning, we have a really interesting use case, an interesting customer. The challenge they're trying to solve is a pretty universal one. So how many parents do we have in the audience? Quick hand raise. Few, maybe 50-50. All right. So if you're a parent, you'll know what a challenge this can be. Both Sham and I are parents, about 10 years out from this phase, so it's luckily not quite the issue that it used to be. But we have a customer who's looking to help parents enable their babies to sleep better. So Cradlewise is a maker of smart cradles. And their goal is to be able to help soothe babies back to sleep just the way that a parent would, but without the parent having to get involved. Lets the parent get a little more sleep. And to tackle this, they really kind of took a two-pronged approach. So the first piece was that they wanted to give parents the ability to control this cradle from an app, and they wanted to ensure that this functionality would still work even if the connection outside of the house was down. So even if your networking router was down, it shouldn't affect your ability to interact with the device. And second of all, they really wanted to take into account the fact that every baby's different. So if they're using machine learning, could they tailor the music? Could they tailor the speed of the rocking to a specific baby and improve that over time? So given this approach, Cradlewise was able to utilize capabilities already baked into AWS IoT Greengrass to ensure that A, the cradle continued to operate disconnected. That's a core piece of what Greengrass gives you. And also, they were able to leverage the over-the-air update capability that we've built into Greengrass. So let's take a quick look at what their update architecture looks like. So they're running machine learning in the cloud. They've got a new model ready. It's ready to be deployed. What happens next? So first off, they're going to send an update trigger down to the device. Next, they're going to send over a permission request to the parent, make sure it's an OK time to go ahead and do this update. Then, once they've gotten that permission grant from the parent's app, then they'll go ahead and pull down the model from S3 and go ahead and update that on the device. And once that's completed, they'll send back a status update. So having support out of the box for this type of capability and this type of workflow, it meant that Cradlewise was able to focus on their part of the problem, the helping babies sleep part of the problem. And they didn't have to worry about how to work in a disconnected state. They didn't have to worry about how to manage over-the-air updates. Given that we know these kind of data-driven cycles, these data-driven features are so important to customers, we've recently added a new feature to Greengrass. So we just added support for a new feature called Stream Manager. And what Stream Manager gives you is APIs for managing high-volume data. So as I mentioned, we have Device Shadow, which enables you to manage state information about your devices. but it's not really meant for high volume data. It's not meant for kind of sensor volume data, many, many readings in a very short amount of time. And so what we found was that customers really needed this type of capability. We had a lot of customers who wanted to have an edge device where they were able to locally connect data and maybe even visualize that locally, but then also provide a sync capability up to the cloud. And so with the Stream Manager APIs, you get this type of capability. So what are you able to do? You can create streams, and more importantly, you can set different types of policies. We ran into customers who were kind of trying to implement this themselves, and it turns out, on its surface, it seems not that hard, but it turns out once you kind of get into a lot of the edge cases, a great example is, what if you start running out of disk space? Do you want to be preserving, your oldest data, or is the newest data more important to you? These are all the types of considerations that you would need to code up, and we give you the ability to just set that using the APIs. So you set up ahead of time, is this a stream that I want to preserve the newest data, or do I want to preserve the oldest data? You can also set priorities. So you can say this stream is more important to me, and I want it to be synced up to the cloud first. And then finally, we give you a couple of different cloud-side targets. So you can sync your Stream Manager data up to either Amazon Kinesis or IoT Analytics. And one of the really neat things here is when you combine this with our container support, it gives you the ability to run a database and then a UI at the edge, which is really something a lot of our customers were looking to do. So we have one customer who's already making use of this capability. So Lockheed Martin is on a journey to really transform and modernize a lot of their manufacturing capabilities. And so, as a portion of that, what they've started doing is building a data lake in the GovCloud region. And so what they wanted to do was use Greengrass in their factories to, first off, just reduce the amount of paper that they were using. It was a situation where that was, there were still processes that were paper-based. And in addition to that, now that they're able to sync this very high-volume data up to the cloud, they're going to be using that to drive insights, to drive transformation, and improve, optimization of their facilities. And rather than continue talking, I am going to move into the demo portion of the presentation. So let me switch over. Actually, before I switch over, I am going to mention that turns out whether or not to do a live demo versus a recorded video is a very hotly contested topic. I polled a lot of folks internally, and folks, it was about 50-50. People either said, you absolutely have to do it live, or people said, why would you do it live? That's crazy. So I took the belt and suspenders approach. I have a video, and I'm also going to attempt to do it live first. So bear with me if things go completely sideways with the live version. I am absolutely playing the video. You have been warned. So what's our demo look like? So I'm going to kind of give you a little bit of setup here. So in this case, everything on the left, everything in green, that's our edge. In our case, I'm using an EC2 instance. Maybe not quite as exciting as some tiny thing at the edge, but that's what we're using for demo purposes. And then on the right-hand side is everything that's cloud side. So what I have running on my Greengrass core device, I've got 3 different Lambda functions. And you'll see I have 2 different browser windows open. So what's happening is at the very top, we have this simulated sensor data. That's coming in from one of the browser windows. So I'm able to adjust and toggle the sort of simulated sensor readings and send that into this writer lambda. So the writer lambda, it's a Python function. And what it's doing, it's reading that simulated sensor data, and it's writing it out to that local data stream. So that's just a raw, all of the readings it's getting is just writing to that stream. So then we have this lambda function in the middle, this aggregator function. It's reading from that raw stream, it's calculating some averages, and then creating this aggregated local data stream. And so in this case, it's just calculating averages, But this is a really common use case where you're taking very high volume data and doing some sort of transformation on it. So whether that's downsampling it, calculating an average, calculating some simplified version, so that at the end of the day, what you end up pushing up to the cloud is reduced. So it's not quite as expensive to be sending that full volume data. You're only sending the most valuable bits. So our aggregator does that averaging, writes it out to that second stream at the bottom. And then at the very bottom, we have our third Lambda function, which is a reader. So that's going to read data from our averages stream, and then it's just going to visualize that. Well, and actually, I should say, the local data display panel at the bottom, it actually visualizes both of our streams. So it's going to be reading from the raw data, and then it's also reading from the average data. OK, so then cloud side, what we're doing is, so for each of those streams, we have then Stream Manager automatically exporting that to Kinesis. The trick is we've set it up so that the bottom stream, our averaged stream, has a higher priority. So we're going to expect that one to sync up first. And then I've got a UI that's reading directly from Kinesis. So you'll see kind of on my local desktop, I have a UI that's reading straight from Kinesis. So that's the cloud side picture. The other UI, it's reading from my local edge device. All right, everybody with me? OK. Here's our setup. We've got our sensor input panel. Kind of behind it, you can see there, we've got our local UI that's local to my edge device. And then kind of hiding behind it here, you can see the UI that's looking cloud side. All right, so I'll go ahead and run this. Go ahead and run this. All right, here we go. Excuse me. OK, so you can see we've our sensor panel is generating data. Right now, it's not changing. So you can see we've got these simulated temperature, pressure, humidity values. Excuse me. And right now, they're not changing. On the upper half, I'm scrolling. It happens very quickly, so it's kind of hard to tell. But on the upper half is the raw readings, and then lower down is the average readings. So right now, they're not changing. But now we can start varying some of these readings. So as I'm changing the temperature value, that first Lambda function, as it's reading, now the input that's coming in, it's getting different inputs. So then, as it's writing out that stream, you can see that my local UI, as it's reading that stream, it's getting that updated value. And then if we go down, we look at our average value, you still see kind of a similar fluctuation, kind of smoothed out a little bit. And then this is looking cloud side, so that's getting synced up to Kinesis, and we can see that same variation. So everything's working well there, right? We're syncing data from the local data store up to the cloud. So now the next question is, what's going to happen if we lose connectivity? Right? That's where things get hard. So this is what Greengrass takes care of for you, and Stream Manager. So we go ahead. We're going to fluctuate our humidity value. We're still up and running. We can still see that reflected cloud side. Excuse me. And now if we go back and we drop our network connection. So I'm just inserting an IP tables rule here. So we disconnect our network. And we go ahead and we go back and we continue doing some fluctuations. So we keep adjusting our readings. So you can see now we've got our kind of orangish, reddish line. It's now spiking back and forth. But because we've dropped our network, we're not seeing that reflected cloud side anymore. So what should happen once we bring the network back up? Yeah. So what color lines are we expecting to see cloud side once we bring this back up? Yes. So we should see some orange lines. And note where you see the orange lines first. So what did I say about priority? Yeah. So the average one is the one on the bottom. So we bring the network back up. Oh, no. All right, I'll play it again. The screen here locally blanked out right at the key moment. All right, here we are. OK, so we don't have the orange lines yet. And play it forward. Boom, boom. Orange lines. All right, so that's the core functionality of Stream Manager. And with that, I will let Shyam wrap us up here.
OK, thank you, Catherine. And good idea on both the belt and the suspenders. Though it's one of those things, right? If a demo actually does work in the middle of a forest, but nobody's there to see it, did it actually work? So it's probably working. It's just you couldn't be and see into showing it. So thank you again. So just to close up here, right? So we talked about new capabilities we've added in terms of open, secure, and data-driven systems. So my prompt to you, and the opportunity is, in addition to saying what problems could I solve, right, with IoT, reasoning about the data and the state from the state of everything in the world, how would you solve them differently using fully autonomous systems? And these may be, small changes you make now or complete new systems you build altogether. And that's what we're seeing from a lot of customers. People are recreating how they do business with IoT. Very exciting times. And also, how can you leverage the pieces we have? You can take what you want and you can build your systems around it. Or you can take all of it and build a brand new system as well. And we urge you to look into all of the things that we've launched. We also, I want to wrap up with other things that are related, other talks that are related. We have IoT and industrial automation talks. The key for business that Catherine talked about, AMZ 305, we worked closely with that team and really got a great experience. They were able to use Amazon FreeRTOS and IoT Core to really have a great delivery experience for Amazon, and additional talks as well. IoT 337, we'll talk about, on the microcontrollers, how can you actually get really tiny, low-cost systems to actually connect and participate in IoT. And we also have trainings. So we have IoT-specific trainings. You can have digital courses and so on and so forth. So again, thank you so much for joining us. And takeaway is to really think about how you can use our products. Give us feedback. Love to hear from you. And really think about how you can transform your business with these autonomous systems that connect devices to the cloud and really close that loop. Thank you.